It's basically our penultimate presentation comes to us from Vahit Atakan, who's the Director of Research and Development at Solidia Technologies. I am delighted to say that Dr. Atakan received his PhD in Material Science and Engineering at Rutgers. His research expertise is in material science and innovation. He's also the co-inventor of Solidia's core technology, along with Professor Richard Ryman of Rutgers, and he oversees planning and implementing research that serves as the foundation for developing new applications at Solidia Technologies. One of the focal points of this conference was to show not just an exercise in nostalgia, the history of technology, et cetera, but really to emphasize what is happening today and what will be happening tomorrow. And so, in fact, when we heard from Princess Marconi about her own exciting initiative, but especially to see how Invention is alive and well and thriving and will continue to thrive in the state of New Jersey. Dr. Atakan.
Yep, thank you very much. And thank you for the opportunity for speaking here, and it's really a pleasure. And let's see. Okay, so with the onset of the industrial age, we have been using more and more resources, and we have been emitting more and more CO2 because of fossil fuel consumption. And there's a big effort in the industry, both in big companies and big venture firms. They are looking for solutions about how can we turn the CO2 into a useful product. And while those companies are thinking about this, back in Rutgers in 2007, I was working with Professor Ryman about a bioceramics that we were trying to sinter ceramic particles at very low temperatures. So the sintering of ceramics is like you start with ceramic powders, and you heat them up to very high temperatures so they fuse together. So the problem with this is there are some ceramic materials that you cannot sinter because they decompose before you reach that temperature. So we were working on a technology that would enable us to sinter these materials at almost room temperature. And then what this enabled is we could sinter materials like calcium carbonate, or you can call it the synthetic marbles. And then while we started intersecting with Kleiner Perkins, that is one of the biggest venture firms in the US. And they were looking for, can you hear me? All right. So they were looking for solutions. They heard about our technology. And they said, OK, how can we use your technology and make an impact in the world? So the solution to this is not small objects. We had to go larger objects. And the volume has to be there. That is why we decided to work on building materials, because concrete is the second largest substance that is used in the world after water. So if we could incorporate our technology in building materials, we believe we could make a big dent on the environmental footprint. And then we had to take our invention and we had to look at the market and understand the market dynamics. What are the problems in the industry? So in construction industry, the main material is Portland cement. That is the material that holds the aggregate and sand together. And the production is enormous. There is like 3 billion tons of production. And every ton of cement you produce, you typically emit 1 ton of carbon dioxide. So the volume of the CO2 that is being emitted is quite large. And back then, we were working with a natural mineral. And when you compare this natural mineral with ordinary Portland cement, first of all, the problem is this natural mineral wasn't highly abundant. And it was only in 2 geographies in the US. One is upstate New York, and the other one is down in Mexico. So we didn't have the volume, nor we didn't cover the whole area. So this was a big challenge for us. And we had to step back and take a realistic look and see, OK, how can we overcome this? So what we decided was, OK, if we don't have the mineral, Let's either try to find another mineral that's going to do the job for us, or let's synthesize the mineral by ourselves. So we took the second approach. We tried so many minerals, and you search the literature, use the libraries, of course. There wasn't really nothing that would work for us. So we decided to go ahead and synthesize our mineral. And in this graph, I like to show you that the cement industry, they are trying to decrease their CO2 emissions. By 2050, they like to decrease their emissions by 50% or more. And in order to reach that, they are using more energy-efficient kilns. They are using alternate fuels. And they are blending their cement with some alternative cementitious materials. But this doesn't really bring them to the level that they want. And the next solution is carbon capture and storage. And this is very expensive, and implementation is quite challenging. So we come up with this next idea of, OK, instead of making Solidia, ordinary Portland cement, let's synthesize our mineral, and we call it Solidia cement. And when you look at the ordinary Portland cement, most of the CO2 emissions, it comes from two sources. One is the fossil fuels that you burn, because you have to heat the raw materials to 1,500 degrees centigrade. And the second one is the use of limestone. Because when you heat limestone, it's going to decompose, and it's going to a lot of CO2. So with our Solidia cement approach, you can see on the table, we are using less limestone, and our firing temperature is significantly lower. So this results in a 30% CO2 reduction. And another important factor in this is, once we developed our Solidia cement, we put some constraints to us. Because the cement plants, they are built on the quarries, and they cost around $300 to $400 million. They are huge, so if you like to bring a solution, you don't want to disturb their system so much. So what we said is, OK, we are going to use their equipment, and we are going to use their own raw material. So they don't need to make any changes in their equipment facility. And at the end, we did successfully some industrial trials. We have around 5,000 to 6,000 tons of Solidia cement produced. And that was quite successful. And then this is a typical image of a cement plant. This is in upstate New York. And a little bit more in details about the cement. The average price of a cement is like $100 a ton. Your production cost is $50, and you cannot really transport this material more than 200 miles. And then when you compare OPC with our Solidia cement, we are going to save some money from the raw materials. There will be some savings from the energy, and there will be some savings from the CO2 emissions too. So we are talking about like 10% of an benefit to the cement industry. So this is quite important. And like I said, the volume of cement is, we are talking about 3 billion tons of cement a year. So the volume is huge. And then cement, of course, it's one of our inventions. So compared to Portland cement, typically what you do is you take Portland cement, blend it with sand and aggregate, you put water, you wait 28 days, and your product is ready. When you compare with Solidia cement, we already provided 30% of CO2 reduction during the cement production. We blend it with sand and aggregate as well. We use water for shaping, but we do not consume any water. Instead, we react with CO2. And at the end, in less than a day, we have the Solidia concrete with similar or improved performance. And this additional CO2 curing, we can go up to 70% of CO2 savings in certain products. And remember, the cement industry is trying to find solutions, and when they improve their CO2 emissions by a couple of percent, they get very happy. So this number is quite significant for them. And then, of course, since this cement is very fragmented and it's a very global industry, For example, let me give you an example. One of the biggest cement producers of the world, they occupy only 5 to 6% of the market. So that's why, as Solidia Technologies, we are not in a position to manufacture our own cement in our cement kilns. Instead, what we are doing is we are collaborating with the industry. So we are licensing our technology, so this is widely accepted. So these are some of the financial and industrial organizations that we collaborate. Kleiner Perkins was our initial venture firm that give us the funding, along with Bright Capital. And BP and BASF are also, their venture arms are working with us. They also provide a lot of useful connections in the industry. And in addition to that, we have Lafarge, the French cement giant, is also working with us on development and commercialization of Solidia cement and concrete. In addition to industry, we are working closely with the government. We are working with US DOT, Department of Energy, and EPA. With this, the advantage of working with the government is they help us to make connections with other companies. They help us on product codes and approval. And because this is yeah. And cement and concrete industry, it's very, they've been doing this for over 200 years and they don't like changes too much. So changing their process is very challenging. So the government agencies, especially with the codes, they are helping us so that our technology can be widely accepted. And I like to, the next column, I find it very important as a researcher. Our technology, it started with Rutgers back in 2007, late 2007. And then we quickly noticed that our invention was way beyond our capabilities. So we decided to work with the other universities who are the pioneers in their field. For example, Purdue University, they have a very strong civil engineering department. So we could get the third-party credibility and validation as well. And the second one is Ohio University is a very big corrosion institution because the durability of the cement is quite important, the concrete. So that's why we are working with Ohio University and South Florida University. Instead, we could say that, okay, we are smart people, so we can tackle all the problems by ourselves. This is one approach, but this wouldn't really take us to where we wanted to be. And it would take a long time, and we couldn't spread our technology. That's why we find this very important. We still fund the work in Rutgers, and also we are leading this technology, and the other universities are very happy to help us. And then I will give you a brief overview of what we are doing. On the left-hand side, you say this is the cement part. We use the same raw materials that the existing cement plants use. We use the same equipment. And when it comes to the concrete part, we like to change as little as possible because we don't want to cause trouble to the industry. We would like to help them enhance their products. So we use their own equipment, the same mixer, same forming equipment. And the only change we do, we try to make it as little as possible, is on the curing chamber. And then when it comes to going into the market, since concrete is a very big market and it's fragmented, we have to show the industry that we can do this in a financially feasible way. So we selected the cheapest product that you can ever make with concrete. And it is the pavers and blocks. It has another advantage. The code regulations, they're not really so strict on this. So if we can show the industry that I can make pavers and blocks and make money out of it, this means that I can make any other concrete product. So this is why we chose pavers and products, and in this list you see some of the advantages that we provide to the pavers and block industry. And you can see the volume of the market is like around bigger than $18 billion. So it's a significant number. I'll skip this one. And then I think this is a very nice plot. We got it from GE. What is the impact of innovation and what drives innovation? We strongly believe in collaboration. Our technology, it originated from the university. So we pay special attention to universities and we keep funding the research in universities. We work with 4 different universities. And we find the patent protection is quite important. We select the geographies that we go to that we make sure there is patent protection. And private investors and government support is very critical. And we make better products, so we are aligned with the competition. And we create jobs. So this is this aligns well with what impacts innovation and what is the driving force behind it. And in my last slide, we also believe that, okay, being green is good and sustainability is important, but it cannot be a burden to the companies. So whatever solution we propose, it has to meet the profitability. So it has to add value, and it has to add value to the society, and society has to benefit from that. And thank you. Any questions?
Very impressive. I think we have time for one question, and I'm also going to bring Princess Marconi to prepare for the book signing. We're almost there. We have one more presentation. But having just put more than a few concrete pavers in my own garden, I was all eyes for... I can see where the profitability came into the equation, but... Great, yes. I saw a hand. Yes.
Yeah, but that's a very good question, and that's one of the reasons we work with Purdue University. We have a very extensive durability program with them. And then we are doing our tests, and the results seems very quite impressive so far. Yes?
Does Solidia offer the same options as regular cement as far as low temperature cure, underwater cure, and so forth?
Well, underwater cure is a little bit questionable, but other than that, we are focusing on precast market right now. And then underwater may be a challenge at this stage. But like I said, precast market is 20% of the whole concrete market, and it is quite huge. So we would like to keep it at that level. And then we have our research project still with Rutgers, trying to expand our capabilities.
I've returned. Thank you very much.
Yes,
This has been fantastic.